Understanding Python. My name is Jake, and today I'm going to be going over what is likely the most versatile data type in Python: strings. Strings are incredibly flexible and can be used to store just about any kind of data you can think of. With a strong understanding of strings and how to manipulate them, you can open up a ton of possibilities in your Python programming. Now let's get started. So what are strings? Well, strings are immutable lists of characters, but unlike other languages, those characters in Python are actually strings themselves instead of a separate character data type. Now let's get started with creating some strings. If you remember my previous video about data types, we created strings in a number of different ways, so I'm not going to do a complete review. I'm just going to create a basic string here. And we'll just put in the contents of this, review my data types video for more string examples. Okay, so this is a string. Now the syntax here is that it's surrounded in some sort of quotes, whether it be double quotes here, single quotes, or even the triple string quotes, as you saw in the previous video. Now everything inside of here is part of this single string, and if you were to separate anything like a single character in here, this Y, that would also be a string and have the same properties as a normal string. Now to give some more about multi-line strings, or defining strings across multiple lines, there's a few important properties about Python that you need to get down. The first is that any white space between strings will be removed and those will be combined. So let's create a new string here called multi1, and we'll just make a string by itself. This is all one string. Now say that this was a really long string and you wanted to break this up across multiple lines, you can just chop the string up like this, and then you can spread these across different lines. Now if you were to just try doing that like this, then you're going to have multi equal this is, and then these two statements here will just stand on their own. They won't actually get assigned to anything. They'll technically be created within Python, but since nothing is referencing them, they'll be garbage collected fairly quickly, so you're going to lose them. In order to get around this, to have Python consider this all one string, you put a backslash here. So this makes it so you can actually combine all these together. So let's just go ahead, add a little bit of formatting here so it reads a bit better. And when this is ran, multi1 would become this is all one string. Now another way to do this is to wrap everything between parentheses, multi2. So we'll initially put some parentheses here, and then in quotes we'll say this is another string, and we'll chop this one up as well. And then we'll break these down into their own lines. There we go. And then anything between these will be combined into a single string. This is another way that Python makes it easier for you to make strings across multiple lines and put them all together. Now if we want to make the formatting a little bit better, we can bring this down here, bring this back over, bring this back over, and then finally put the ending parentheses down on another line. In my opinion, that looks significantly better. Now if you remember from the previous video, you can always use the triple quote strings to make multi-line strings. So we'll make one here, multi3, and we'll do triple quotes, and then say use triple quotes if you want your string to preserve Newline Characters. So I'll end that. Now the difference between this and these up here is that when you use the triple quotes, Python interprets the end of the line here as a new line character. So when you hit enter, it creates a new line character here. So when you actually access this multi-3 string, you'll see that new line characters are inserted here and here. Now if you don't want the new line characters, you can do this. Multi-4, we're still going to use the triple strings, and we'll say if you don't want, and then a backslash here, new line characters in your multi-line, another backslash, strings, comma, use this character. And just for good measure, we'll do another one and close this out. Now one thing to note is that with these triple quote strings, if you have extra white space to the left here, those will be preserved. So if you don't want to have a bunch of extra white space, then you want to go ahead and bring this in. So we'll go ahead and bring these in all the way to the end. And now, since we have the extra space here, it's not going to give us a ton of extra space in the string. And we'll see that a little bit later when we print those out. Now another way to create strings is to convert other objects or other data types into strings. And to do that, we have the str method. This is built into Python. You can put most objects into this, anything that technically has a dunder str method or a dunder repr method, things that we'll be covering in later videos. So first we'll start off with just a random integer. Here we go. And then you can also do lists. So we'll do a new list here where we'll have 1, 2, 3, 4 inside. And then we'll also do a dictionary where we have string representation of 1 mapping to 1, 2 mapping to 2. Then we'll do 3 mapping to 3. And I'll stop there as you get the point. One thing to note here is that when these are converted into strings, everything you see in here will be represented in the string itself. So that is both the square brackets and the commas. And then down here we'll have our curly braces as well as commas and colons. If that's not something that you want, there's a way that you can pull these all together into a new string, and you can actually format them however you want. And the way that we do this is with the join method. So I'll do an empty string dot join, and in here we can do a new list where we say a test string. So now we have a list in here whose members are a, test, and string. Now one thing to keep in mind is you can put anything in the string that you're calling this join method on, and anything that you put in there will be what is put between the entries in this list. So if we wanted to do something like 3 tildes, then the string will look like a, 3 tildes, test, 3 tildes, string. Now most times people use this, they either do a comma and a space to do a comma separated string so they can process it easier later, or just a space if you want to put a bunch of words together into an actual sentence. The choice is really up to you and how you want to make your string. Another one of the basics of strings is understanding string literals. These are special characters that Python interprets to mean something other than what it looks like. Now you've already seen one before, which is the form of that backslash. and this is what's known as the escape literal. So say that you had a string that had double quotes here, but you wanted to use double quotes within your string. Now you may see an issue here is that it thinks that it's starting a new triple quote string. Or if you had this within here, so we'll say something else, Python thinks that this string ends at something, and then this is actually a separate statement, and then we have a new string starting here. If that's not what you want and you want this to actually be interpreted as your double quote with inside the string, use your backslash, and now that escapes the double quote here, so it'll actually be interpreted as it is. And now you see that my editor returns to normal, and this is considered just a single string. Now, similar to how we just escaped the double quote there, if you wanted to actually represent a backslash within a string, you can escape that with another backslash. So these double backslashes will just become a single backslash within the string. One thing that's more common and that you're much more likely to do on a regular basis is to insert what's known as a Newline character. So in Python, we represent that with a \n. So this will create a new line or a break in the line, if you will. Another useful one is going to be the \t, which represents a tab or a tab indent. You can use any of these throughout your strings at any point to give you the effect that you desire. Now there are a number of other string literals, but in my opinion they aren't as commonly useful as these ones. But if that's something that you want me to get into, let me know down in the comments and I can dig into those as well. Finally, under basics, we're going to cover the three main types of strings in Python 3. Now, a normal string in Python, which is what you've seen so far, is actually what's called a Unicode string. So in Python 3, as compared to Python 2, strings are now Unicode encoded. In Python 2, it was UTF-8 by default, and then you had to explicitly put a U in front of a string when you wanted it to be explicitly a Unicode string. Since in this tutorial, we're only going to be covering Python 3 plus, as Python 2 is now end of life, we're not going to look back to those old UTF-8 strings. Another type of string you can use in here is what's called a raw string. So raw strings are a little bit different in that they do not format these literals as we saw above. So we'll say raw doesn't. We'll do the double backslash format and \t literals. So as you see the difference in color in my editor, whereas when we did the double backslash, the /n and /t, those had a different color because it lets you know that these are actual literals within the string. When you use raw strings, those actions aren't performed. So what you see is what you get within this string. And then the final one I'm going to cover is bytes. So bytes is something that you may not have to work with much on your day-to-day Python, but it's something that comes in handy when you're working with certain types of files. So if you're working not with straight text files or files that are text encoded, like you'll also see with JSON data or YAML data, or a number of other common configuration type files. Certain files consist of bytes, so it's best to use a byte type string if you want to read or write from them. Okay, I'm going to save some of these ones up here into variables, and then we'll get into IPython and take a look at each of those. Okay, that's been saved. So now we can go into the string directory, and then we can do ipython -i, and this is called basics.py. Okay, so everything's been loaded in. Let's start at the top. So we see we have our basic string, and that's just a normal string. Let's take a look at multi1. You see how all of this was put into a single string here. Then we have multi2. Again, it's a single string because everything between these parentheses were put together. Now multi3, we should, here you go. If you look at this, we see we have a /n here between the lines. That's because, as I said, everything here and here, as we give it a line break, is considered a new line in our triple quote string. Now if we look at multi4, that shouldn't have that behavior. And here we see multi4, it doesn't have any new line characters in it. Perfect. Now let's take a look at our converted strings. So we'll say int string. And we see if we have a string representation of that integer. Now we have list to string, which again is a perfect string representation of the list, including the square brackets and commas. Then we have our dictionary to string, which, as you'd expect, is a perfect representation of the dictionary as a string, including curly braces, commas, and colons. And then finally, if we take a look at joined, we see we have the 3 entries in our list that are separated by the characters that we put here, which is our triple tildes. Now if we look at lit1, we see that we have something else with our double quote here interpreted exactly as we expected because we escaped it. Now if we take it lit2, now this is something that looks like it didn't actually come out correctly, but this is just something that IPython shows you. So in actuality, if we were to print this, print lit2, we see we just have the single slash there. That's because IPython is actually showing me both characters to give me a hint that there's a literal that hasn't been interpreted. If we were to go back up to multi3, see how it shows that Newline character in there? If I were to print that, multi3, then it actually prints out how you'd expect it to look. So it no longer shows the Newline character, it actually interprets it and carries on a new line when you print it. The same will be true for lit3. So if we look at lit3, we see the Newline character. But if you print lit3, we just have the extra space in there as the new line was interpreted. And the same is going to be true for lit4. Print it out. Lit4. Now in here, it's kind of hard to see because there's no actual characters after the tab, but there is a tab that was interpreted. Alright, so looking at normal, we can see that is a normal Unicode string. If we take the type of normal, you can see that it's a string. If we look at raw, we can see that IPython's going a bit overboard to escape it within itself, but if we print this out, we see that raw doesn't format literals. So the new line was interpreted, neither was the escaped backslash or the tab. And then finally we have the byte, which is a byte string, and in front of it you see that it has the B, annotating that it's a byte. Printing out shows it's the same thing. Let's get out of IPython, clear this out real quick, and they'll move on to the next section, which is strings like list is the file. So since strings are a lot like list, or they are a list of characters that again are strings in Python, they can do a lot of the things that lists can. So we'll make a new string in here called myString. As you may all know if you've been following the series so far, I'm extremely descriptive in my variable naming because of my immense creativity, which does not exist when it comes to variable naming. So we'll just say this is a test string. Now, just like lists, you can get the length of a string by calling the len method against it. So len of myString will give us the length of this string. You can also access individual elements in a string the same way you would with a list. So we'll go myString 0 would give us the first character in the string. In this case, it would be a T. You can skip straight to the 8th character, or just like lists, you can work your way backwards with negative numbers starting at -1 to get the last character. Now, one thing to remember that's different about strings as compared to lists is that strings are immutable. So you can't do something like this. myString 5 is equal to Q. So strings being immutable means that you cannot change a string once it's been created. So everything that you do when you alter a string, you have to assign it to a variable to store it in. If we were to run this right now, let's go ahead and save it, we should get an error on line 8. So we run this, and here we go. We have an error on line 8 saying type error, string object does not support item assignment. And that is because it's immutable. So we'll go ahead, comment out this line, and say strings are immutable. Now, another thing about strings that is neat to do that are like lists is you can slice them. So if we go from 3 to 7, that would go from the 3rd index to the 7th index, giving you a substring of that. And a substring is just a new string that meets the 3rd to 7th index. Continuing on with how strings are a lot like lists, you can combine two strings with a plus. So we'll just create two junk strings here. Sure, that plus that. Now when you run that and assign it to a variable, those will be put together into a single string. And another thing that's similar to lists is that you can multiply strings. So we can say myString times 5, and if you want to do that the same way with the string, you can do times equals 5 to handle both the multiplication and the assignment. So the result of this multiplication will be stored to myString, whereas above it's just doing myString times 5, but it's not actually assigning it to anything, so you're not going to store that value. myString will remain exactly the same. But what does it mean to multiply a string? Well, really what's happening here is it's just repeating the string multiple times. So if we were to copy this, the effective result of multiplying this particular string by 5 would look like this. 1, 2, 3, 4, 5. So it just puts that all together into a single long string. Now this might not seem useful if you're just doing a normal sentence or something like that, but this actually does come in handy if you want to do some type of custom string padding or something else. I'm sure you can think of really creative use for multiplying strings. In my experience, it's not incredibly common, but it does have its uses. Okay, I'm going to add some print statements in here, and we'll take a look at what's happening. Okay, all the print statements are in place. We're originally going to print my string up here. And then at the end, instead of printing while this is happening, we're going to print after the fact. Actually, let's go ahead and add another print statement right below here, so you can see that since we didn't actually assign anything to my string at that point, my string remains intact. So we'll save this, run this, and see what happens. Alright, we see my string is equal to this is a test string. The length of my string is 21. My string at position 0 is T. At 8, it's A. At -1, or the last position, it's G. Then from index 3 to 7, we have S space is. And then we see something interesting here. So on the left here, it actually added them together, because if this is something that you caught while I was doing it, we didn't put any escape characters here. So these were interpreted exactly as they are. So if we were to escape this, and then escape this, then that should work perfectly fine. So let's save, replay it, and here we have exactly as we expected. AOSDN plus that string becomes this together. Then we have my string times 5 is this is test string, this is testing, this is test string, etc. 5 times over. But after that, because we didn't assign it to my string again, we see this is a test string as normal. Now, we didn't print out line 14, but line 14 did have the effect on my string. So when we see the final print statement is it being printed out 5 times. So that's a brief overview of how strings operate like lists, or things you can do with strings that you can also do with lists. There are a number of creative things that you can do with these type of list-like properties with strings. Some of them will be covered in a file over here on the right. But first, let's get to a very useful thing you can do with string, which is formatting. So with formatting, you can inject data into strings upon creation. Now, what do I mean by this? Well, let's just create a initial string called name, make that equal to Jake. Now, there's a number of different styles of formatting. As Python has gone throughout the years, it's added new, sometimes more efficient versions of formatting, but we'll start at one of the oldest and make our way to the newest. So the old style is in a string, you would say my name is, and then %s. So the %s lets you know that you're going to be formatting something in here that is a string type. And then after the string is defined, you put a % and then the variable. So what's going to happen here is that name, or the value within name, is going to replace this %s. So it'll end up being my name is Jake. A second example of this is if you wanted to inject multiple values into this one and you wanted to do it in a bit of a smarter way. So we'll call this old style 2. And we'll say my name, and we'll say %, and then within parentheses we'll say name. You can really call this whatever you want, just as long as it's something that you know how to reference later. We'll go ahead, add in a Newline Character. The space really isn't necessary, but it's just there for readability. And we'll say favorite number. It would help if I could spell number correctly. And then in here we'll say %, and then in more parentheses we'll say num, and then put a D there. So the D lets Python know that it's going to be formatting it with a digit value. And then again at the end we're going to do a %, but something that's a bit differently is we're going to be passing in a dictionary, mapping the names that we gave in here, name and num, to the value that it's supposed to get replaced with. So we'll say name maps to name, and then num is going to map to the integer or digit 5. So you don't have to define everything before you format your string. It can actually be done at the time that you're creating it. So if you wanted to inject some random data, or you wanted to loop through a series of values, you can do the same pattern here, just switching out these values, and then you have a series of formatted strings with these injected in them. Now as Python matured, it came up with a different way of formatting strings that some definitely prefer to the old style, myself included. This will be formatted is equal to a, and then we're going to put 2 open and close curly braces string, and then we're going to do dot format. So this is a method that we're actually acting upon the string on the left, and in here we're just going to put a string in here called test. So this is going to become a, and then where you see these curly braces here, that's going to get replaced with whatever's in format, in this case test. So it'll become a test string. You can also do something similar to what we saw with old style 2 if you want to put multiple values in there and also hint as to where they're supposed to be placed. So we can say formatted 2 is equal to a, we'll just say var1. It's not very creative or descriptive, definitely a bad name if you wanted to do production code, but this is just an example, so it'll suit it just fine. Also do var2 and then dot format, and then here we're going to do var1 is equal to test, and then var2 is equal to formatting. Now unlike above where you pass in a dictionary, this is actually doing key value pairs as arguments to format. If you're creative and you already know the answer of how you can pass in a dictionary to format, then fantastic. For those of you that don't know how to do that, I will be covering that in a future video. Now there is a way using this format, or a method that is very similar to format, to pass in a dictionary like we saw in old style 2. So map format is equal to, and we'll just make this short, say p1 space p2 space p3, and in here we're going to say dot format map. So this is different than normal format, and here we're going to map p1 to a, p2 to test. I'll make that an uppercase T, sure. And then p3 to string. Perfect. So much like we did with join in the previous file, these will put these particular values in here. Now in this example, it would definitely be better to use join, but if you had any other kind of random characters in here, then that breaks how join would work. So in this updated example, format map is definitely a better way to achieve these results than if you were to use join. And then the final example I'm going to give you in string formatting is the very latest in string formatting, and this was introduced late in Python 3's development. I think it was somewhere around 3.6, maybe 3.7 at the latest. And these are F strings. F strings are amazing. So in order to do an F string, you put an F in front of it. So kind of similar to how we did the R for raw or B for byte type strings, you put an F in front of this to let Python know that this is going to be a format string. And in here, you can just do something as simple as this. So this achieves the same results as we saw in old style 2. You just directly put the value you want inside of these brackets, and then Python will format that. Okay, I'm going to add some print statements and we'll see what each of these looks like. Okay, all the print statements are in place. Now, one thing to note, if I did have my system updated to Python 3.8, I could do this a little bit easier. I could actually print with an F string both the name of the variable and the value. So I could do print F, and inside here I could do F string or old style equals. Now what this would do is that it would print out old style, the name itself, and then equals, and then the value. This is really useful for debugging, but since this environment that I'm in isn't up to Python 3.8, I'm not going to show off that example just yet. So let's save this, run it, and see what each of these looks like. Okay, so we have old style, my name is Jake, old style 2, my name, Jake, and then we see a line break here because we have that Newline Character, favorite number 5. Then we have formatted, a test string, formatted to, a test string with formatting. And then we have our map format, which is A is D, because we just threw some characters in there, test, ligwo, again, more random characters, and then string. And finally, the F string, my name is Jake. Now, why would you choose one of these versions over another? Well, there's a couple of things to consider. One being the ease of use. For the old style, you do have to annotate what type of data you're putting in there, whether it be an S, D, or other identifiers. While with format, you don't have to specify that. You can just put in any type of data you want and format will take care of it. F strings have the same property as well, but with F strings, if you want to do long strings, then you'll either have to break up the string into multiple lines or figure out another way of truncating the string itself. Additionally, there are performance characteristics to keep in mind, so let's go ahead and look at the 3 methods I've shown above, and we can see what those performance traits are. We'll create a new variable, just simple, make it name, and then we're going to use IPython's built-in timeIt method to test out and see how long it takes each of these to run. So first we'll start with the old style. We'll just do a basic my name is and then %s, and afterwards do %name. We're going to go ahead and run this. It's going to run, I believe, around 1,000,000 times, and then tell us how long it took on average for this to actually execute. Okay, so we see that it took about 157 nanoseconds with a deviation of plus or minus 8.7 nanoseconds per loop over, let's see, over 10 million loops. All right. Let's go ahead and run that again just to make sure we're getting consistent values. Okay, that time was 149 nanoseconds. Not bad. Now let's go ahead and do a timeIt with format. So we're going to do .format name and then change our %s in here to our curly braces. We'll go ahead and run that. And we see that took 225 nanoseconds. Alright, again 225 nanoseconds. So format is very consistent with that. Now if we were to do f strings, let's go ahead and do the time it for that. We're just going to directly put name in there and put an f at the beginning of this, making it an f string. We run it and let's see how long this takes. Alright, so we see that f strings have significantly better performance, coming in at 13.1 nanoseconds with a very small deviation per run of just 0.589 nanoseconds. And again, our second run we get 12.4 nanoseconds with again a very small deviation. So we can see that using f strings when possible will most likely give you the best performance, and in my opinion is more readable for smaller string formatting. Okay, let's exit out of IPython, clear this out, and move on to the next section. And this next section is all about altering the content of strings. Okay, so the first things that we're going to cover in altering strings are methods available to the string objects that allow you to play around with or alter the casing of the contents of the string. So the first one we're going to do upper, so we'll make a string called a test string, and then we're going to call upper on it. So what this is going to do is it's going to make all of the characters in this string uppercase. Similarly, we can do the same thing with a lower as well. Let's go ahead and just copy this for ease. Okay. And then we'll do dot lower, and as you'd expect, this will make all of the characters in the string lowercase. Now there's some extra methods you can use, like capitalize, so we'll just do a test string and capitalize. And then there's also title case, so we'll just say a test string dot title. And we'll see what this looks like afterwards, but what title is going to do is it's going to capitalize the first letter of each word. So it's going to make it look like we did with our first couple of strings where we had A, T, and S capitalized. Another interesting thing you can do is what's known as swap case. So let's do a test string and then swap case. So what swap case does is anything that is capitalized is going to be lowered. Anything that is lowered is going to become capitalized. I've never actually had to use this at any point, but you might come up with something that you need to swap the casing with. Now, since lower primarily works on ASCII type characters, if you do have to work with expanded alphabets and you're not seeing the best results using the lower method, you can use the case fold method. So I'll just do a test string dot casefold. Now casefold is good for giving you lowered results that work across expanded alphabets or expanded characters. So if you're working with the Cyrillic alphabet or some expanded characters that you might see in a German alphabet as well, casefold's going to do a better job of giving you a proper lowered version of that. Moving outside of just working on different casings with strings, you can also do things with justifying strings left, right, or center. So what do I mean by that? Well, let's go ahead and use our normal a test string here. Say you wanted this to always fill a certain width. Well, you can use, just to start off, ljust, and this takes two arguments here. One will be the width and the other one will be the character to fill that width with. That sounds kind of awkward, but it's going to fill the width with that character. So we're just going to do a width of 20 and then the fill character is going to be X. So it's going to count out from left to right 20 characters. And if it doesn't meet 20 characters, it's going to fill that with X's. So we'll have A, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. And then until it gets to 20, it's going to put X's there. Now if you wanted that to be filled from the left, then you can do rjust, which is very similar to ljust, just swaps the way that it fills. So this is going to be the same thing. Now our index, rjust, 20, comma, x. So whereas the ljust is going to put the x's at the end of the string, the rjust is going to put it on the left. Now if you wanted something to be centered, well, just as you'd expect, Python does have a version for that as well. So we'll make a test string and then dot center. We're going to do 20 again, put our x as our fill space, and then it's going to center what you have here within that 20 character space that you're wanting. So it's going to put x's on the left and x's on the right until it matches that 20. Now potentially a more useful method is the zfill method. So if you wanted to do it just with a normal string, you might not see how it's beneficial. So we'll say a test string dot zfill, and this just takes the width that you want it to be. So it's similar to rjust, as that it's going to fill from the left, but it's going to fill it in with zeros, as in the actual string representation of the number 0. So it's not going to be useful in this example per se, but say you wanted to work with printing out numbers and you wanted to have the numbers look like this. So it'd be 0, 1, 1, 0, 100. How can you take care of this 0, 1 here without doing a bunch of checks to make sure that you actually need to put a 0 in front of it? Well, for that, we can use zfill. So we're going to do a string casting of 1. They're going to zfill it to a width of 2. So in this example, 1 only has a width of 1. So since we need to zfill it to a width of 2, it's going to put a 0 in front of the 1. And similarly, if we were to make a couple copies of that, 10 already has a zfill width of 2, so it doesn't need to do any fill. And then 100, it doesn't need to do anything with this as well. So in the end, we're going to have 0, 1, 10, 100. So that's a more practical application for zfill. And perhaps an application that you may not have seen before. I know in code I've seen a number of people, especially when they're starting out, go through a bunch of if statements to determine the value of a number and determine if they need to put zeros in front of it. Well, you can do that simply with zfill, and if you want to have additional numbers in front of it, you can just increase the 2 to a 3 to a 4, etc. So let's move on outside of doing justifications or justifies and fills, and do a few more of the miscellaneous altering that strings will let you do. One of these is called expand tabs. So if you put the escape character for tabs in here, so we'll do a/t test/t string, normally those tabs will expand to about a tab size of 4. Well, if you want to control that yourself, you can use expand tabs and put in the tab size that you want that to be. So for example, we can do a tab size of 16. So every time that it meets this /t in there, it's going to put 16 spaces in there. It's probably a bit overkill for normal use, but it's something that you can do. Now, something that's significantly more useful and something that you're almost certainly going to use very commonly whenever you're messing with strings, especially if you need to normalize strings or do any kind of string cleanup is these next few examples. The first one being one of my favorites, replace. So say that you get some bad data in here, and instead of saying a test string, it says a test x, whatever, sx ring. So someone is really bad with hitting that T on their keyboard and somehow they're managing to hit X. Well, if you know that you don't need to have an X in there and they're most likely going to be a T, you can do replace. Now the first argument in replace is what you want to replace in a string. In our case it's going to be X, and then the second will be what you want to put in to the string. There's an optional argument for count as well, as then it'll stop after the certain amount of replacing, but for us we're going to keep it just how it is. So what this is going to do is it's going to go through, look for any instance of an X within this string and replace it with a lowercase t. You can also do this for entire words. So we'll say a something string, and then we're going to do replace something with test. So it's going to go ahead, so it's going to go in here. Oh, make sure that we have uppercase S in here because I did put that uppercase in our string. Keep in mind that this is case sensitive. So it's going to go through, find this string something, and then replace it with test. So this again will become a test string. Now aside from replacing things, you can also strip extra spaces from a string. So we'll make one in here, just a normal string, put a few spaces there, say a test string, a few spaces. I'm going to use this for the next couple examples, so I'm going to go ahead and give it a quick copy. Now, say we wanted to remove all of the extra spaces from the left side of the string, we can do lstrip. So this is going to look through and remove all the white space from the left side of this string. This white space can also include Newline characters, tab characters, etc. But for this example, we're just going to keep it with spaces. Say you wanted to do just stripping from the right. Well, like above, we also have our strip. And if you wanted to strip everything from both sides, more simply, strip. And this is one that I use very commonly when I need to clean up results from a string. And then the final method that we're going to cover in this altering is going to be encode. So we're going to do our normal string, a test string, and then simply dot encode. Now you can pass in a number of encodings into here. I believe by default it might be encoding it into bytes. If I am mistaken, please leave a comment letting me know. But in here you can choose different things like, UTF-8 or any other type of common encoding that you would like to have the string encoded as, if you need to maintain compatibility between different types of strings, especially if you're writing data or passing it along to a library that's expecting a certain kind of encoding. I'm going to add a bunch of print statements to this document, and then we'll be back to see what each of all of the prints are in place. Let's run this and see what everything looks like. Okay, so first we started off with upper for a test string, and we see that everything is uppercase. Then we have lower called on it, everything is lowercase. Capitalized, we see that just the very first character in the string was capitalized. Everything else remained the same. Whereas with title, we see that every first character of every word was capitalized, while the rest were left lower. Now for swap case, this one again was fun. Everything that was uppercase became lowercase, and everything that was lowercase became uppercase. Then casefold looks like everything is lowered. If I had expanded characters on this string, then it would attempt to lower them in the most appropriate way as well. And then for our ljust of 20, we see that it puts a bunch of x's at the end of the string. Rjust puts those x's at the front of the string. Center puts the x's on either side of the string. And it looks like it prefers filling out the right side as compared to the left side first. Onto zfill, we see that it put a bunch of zeros in front of our string, just like it did with the x's on our rjust. But in our example here, we see that we get 0, 1, then we have 10, and then 100, exactly as we were expecting with our zfill of 2. So if that's something that you're trying to solve for yourself, just use that simple method of converting your digit to a string and then use zfill on it, and then you can print it out exactly how you want. Now for our expanded tabs, we use the tab size of 16, and it looks like we have about 16 characters that replaced what the tab was in our normal string here. So we just had the a test string with tabs in between each, and those got expanded to 16 characters. Then we replaced the x with the t to bring it with a test string instead of a texic I can't even pronounce that. String? Yeah, sure. And then we replaced something with test to bring us back to our test string again. With lstrip, we see that took care of the extra spaces on the left of the string, whereas rstrip left them alone. And then strip by itself took care of characters on both sides of the string. And then finally, when we used encode, we see that by default it made it a bytes type string. Alright, let's clear this off and move on to the next area. So testing contents of the string. There are some in here that are going to be very useful and that you're going to do quite frequently, and then others that you're probably not going to check quite as often unless you're writing tests for your framework, which I highly recommend, being a quality engineer myself. So the first thing that we're going to cover is what's known as the membership test. So I'm just going to go ahead and write it out and explain what it does. So we'll say E in yes. So this is a truthy type check to determine if the string E is in the string yes. In this case, we know that it is. So it's going to return true in this case. If we were to do X in yes, it would return false. This is useful if you want to do membership checks in your if statement. So if you want to do something like if test in a test string, do something. That'll work just fine. It'll let you pass through. So let's go ahead and annotate that this is going to return true and that this is going to return false. So those are basic membership tests, and that's something I'm going to be covering much more in a featured video. So we'll just leave it at there for today. Now another thing you can do is you can count the amount of times a string occurs in another string. So we'll do our typical a test string, and we're going to use the count method to count the amount of times that the lowercase t string occurs in there. And this should give us 2. as we see it at the end of test and near the beginning of string itself. Now say you wanted to find where a particular string or substring is within a larger string. Well, you have a few options for that. So we'll make our typical a test string. Let's go ahead, copy this because we're going to be using it in the next few examples. I'm going to use .index, and then we're going to search for E in here. So what index is going to do is it's going to go from left to right throughout the string and find the first instance of that particular value. In this case, it's going to give us E here. Now, if it doesn't find the character, it's going to give you an exception, specifically what's known as a value error. So we'll say value error if not found. If you don't want to have to handle an exception, strings differ from lists in that not only do they provide you index to find the position of something, they also give you a find method. So we'll say a test string that find E. Now what's different about this is it doesn't give you a value error. Instead, it returns -1 if not found. So you can do a simple check to say find E within that string. If the value is not -1, then it must exist in the string, and then you have the position for it, instead of having to wrap your index in a try except context. So that way if it does give you the value error, you don't have to explicitly catch that or your program will stop. So similar with these as what we saw in the previous file, not only can you search from left to right like you do with index and find, there's also a right version of these. So we'll do Are index of E, and then Are find of E as well. So what these will do is they'll actually search from right to left. This is useful if you're wanting to search from the end of a string instead of from the beginning of a string. A couple other useful methods along the same vein is starts with, which we can check to see if a string starts with something in particular. So tes, and then ends with, so we can check to see if the string ends with a particular value as well. So we'll see if this ends with ring. So these ones are also pretty useful. Typically what I see is people using starts with. Ends with isn't nearly as common from what I've seen, but it certainly has its uses and something to keep in mind in case it comes up in the future. Now the next section that I'm going to be covering within here is all going to be checking the contents of the string, specifically if the entire string meets a certain criteria. So the first one I'm going to do is alnum, or is alphanumeric. So if the contents of the string are alphanumeric, meaning that they have letters and or numbers, this is going to return true. Otherwise, it's going to return false. In a similar vein, if you want to make sure that all the characters in the string are alpha by themselves, there's also the isAlpha method. So if there's any numbers in this string, it's going to return false. Now if you want to be really strict about the characters in it, you can also check if everything in here is ASCII. So if it falls under the normal ASCII table, if you get into expanded characters that are more Unicode, then this is going to fail if those characters are present. Now, similar to when we check to see if a string had just alpha characters, we can also check to see if they are decimal. So we do is decimal. Similar to that, we can also check to see if it's specifically digit. So is digit. Here we go. This next one isn't something that I've ever had to use. I don't know if I've ever seen it used, but it could be useful if you're coming up with some type of templating library that generates Python code. You can see if a particular string is a Python identifier. So we'll say is identifier. In this case, print is a Python identifier, so this is going to return true. Moving on from is identifier, we can also test to see if all the characters in the string are already lowercase. So we can say a test string all lowercase dot is lower. And this is going to return true because all the characters in the string are lowercase. Conversely to that, we can also test to see if everything is uppercase. So a test string dot is upper would in this case return true. Similar to lower and upper, we can do is title. So a test string dot is title will return true here because the first character in each of the words is uppercase and the rest are lowercase. Now, one thing that's a little bit confusing in these tests are the next two that I'm going to cover. So we're going to do 1337.is numeric. So is numeric is very similar to is digit, but where is digit will fail with expanded alphabets versions of numbers. So if you have the Chinese characters for numbers, is digit will fail, but is numeric will pass. And then another example for something that is still a little iffy to me is the test for is printable. So is printable is a bit weird. It checks to see if a string is what it considers to be printable. So these are our alphabetic characters, our numeric characters, any type of digit. It also includes special characters in there, but one thing that it doesn't consider printable are if you were to put our escape characters in there. So a test and then a Newline character string dot is printable. So this is going to fail because for some reason it considers that tab and numeric character not to be printable. If you know the reason why for that, I'd love to see your explanation, so please leave a comment telling us all why these are considered not printable. And then finally, to wrap it up, we're going to do a test to see if the characters in a string are spaces. So in here we have space and then a tab, another space, and then we'll do new line, wrap it up finally with another space, and then we'll do the is space check. Now since Python considers all of these to be space characters, this is going to return true. Okay, so that was quite a bit. Thanks for hanging in through all of that. If you dozed off, I'm sorry, but I'm going to go ahead, add in a ton of print statements, get these all formatted, and we will print them out, go through the results, and check everything out. There we go. All print statements are in place. Let's run this and take a look. Okay, we see that E in yes returned true, X and yes returned false. The count of T within our sentence is 2. The index from left to right of E was 3. From right to left, again, was 3 because we just have the single E in there. Again, with find, we have 3. Our find, we have 3. We tested to see if our string starts with a test, that returned true. If it ends with ring, returns true. And now something interesting. So here we have is alphanumeric and is alpha returned false for the strings up here. Now, you may already know the answer to this, but there's a reason why these are returning false, and it's because of a property that we saw below. So the space is considered an actual space character. So if we were to get rid of the spaces within this string, then save this and rerun it, we see that is alphanumeric now returns true, is alpha also returns true. And then we see something interesting here when we come down to the is decimal check. So similar to is alphanumeric and is alpha, what's actually triggering it here is the period. The period is not considered a decimal character. So if you were to get rid of that decimal character, it would return true. So what may you ask is the difference between as decimal and as digit, now that you know that decimal does not consider the period to be an actual decimal character? Well, decimal is more strict than digit. So digit actually allows you to enter different Unicode values as well, and that will also consider them to be digit characters if they fall within the definition of digit in the Unicode. It is a little bit confusing, but is digit will also take into account if you have the Unicode characters for something like a number to the power of 2 or a number to the power of whatever you want it to be. These will be triggered as true in is digit, but will not be true in is decimal. Now moving down to our is identifier examples, we see that both print and cheese return true as the identifier, because these actually check to see if they are a valid identifier format. If you go back to my variables video, you can see examples where variables are not considered valid. These are considered valid. If I were to put a 17 in front of cheese, or if I were to put a space between print, then these would then return false. Moving on to the more simple examples, we have is lower, return true, is upper, return true, same with title, as expected with all of these above. Then is numeric, also return true. And then we have our is printable value here, where we have our a test string is printable, and then we have our escape characters in here making this string technically not printable. And then the final example is our is space check, and here we see that all of the characters in this string are considered space characters. Alright, we've got 2 more sections to go through. These ones are going to be shorter ones, so let's continue. This section covers translation tables. So translation tables aren't something that I've messed around with too much, but with these examples, maybe you'll be able to figure out some cool things you can do with translation tables. So let's make a few translation tables. We'll say trans table 1, and we're going to do a tes x sx ring, an example that we used earlier, and we're going to use the make trans method on it. So the first thing that we're going to do is we're going to pass in a dictionary mapping x to lowercase t. So this can make a translation table, letting it know that anywhere in that string where you see an x, that should become a t. Another way to do this, we'll say trans table 2 is equal to the same string and we're going to make trans, and this time we're going to do the x and the t as positional arguments to the method. This has effectively the same result. So now let's go ahead and apply these translation tables. So we'll say trans1 is equal to a des a desx xr ing. I hate typing that out now. Dot translate, and we're going to put in trans table 1. Similarly for the second value, I'm just going to copy it because at this point I hate typing that in. We're going to do trans table 2 to trans table 2. Now let's go ahead, add some prints in here just so we can see what each of these looks like. So do print trans table 1, print trans table 2, and down here we can just simply delete the extras. So we have trans 1 and 2. Save it, print it out, and here we see what the trans tables look like. For trans table 1, we see that we have 120 mapping to t, and then below we have 120 mapping to 116. So when they're applied to the strings that we're translating, they actually appropriately map on there and replace the values. Again, trans tables aren't something that I've messed around with too much, but they are useful for mapping character changes that you want to apply across multiple strings. So let's move on to the final section, which is one of my favorites, which is string splitting. So string splitting is extremely useful and allows you to break strings apart based on some type of delimiter value. So there's a few methods that Python makes available to you for doing string splitting. The first one that I'm going to cover is going to be simply split. So we'll have our normal a test string. Might as well just go ahead and copy this for later. And we're just going to do split. So by default, split is going to split the string apart based on spaces in there. But if you wanted to split it on anything else that you wanted, you can absolutely do that. So let's do a string.split, and we're going to split it on the lowercase character t. So what this is going to give us is it's going to give us the lists with everything that is in between the splits, not including the split characters themselves. One optional argument to split is the amount of times that you want to split these as a maximum. So that's the max split argument. Say that you had a really long string and you only wanted to split it twice, you can put a 2 in there and it'll stop after the second split. However, I like to keep the default behavior of splitting as many times as is needed. Much like what we saw with our previous files, you can also split from right to left. So we can do rsplit. This is useful if you are doing a max number of splits and you know that you want to prioritize the splits from the right side of the string as compared to starting them on the left side of the string. Another option that's available for splitting strings across is called partition. So what this is going to do is going to partition a string based on your quote split character. So what it's going to give back is a 3-element tuple with the left side before the split, the character, and then the right side after. So let's go ahead and do our normal example, and then we're going to partition on the character t. And as you'd expect, we can also partition based on t. So this is going to start from the right instead of from the left. And then the very final example in this file and in this lesson is split lines. So normally if we had our normal a test string and we were to split lines, this isn't going to really do anything interesting for us, but this comes more in handy when you're reading through a file and you want to split each line of a file into an element in a list. You can use the split lines for that as well. So we're going to simulate that by putting in some Newline characters in our string. And then finally we're going to do our split lines and save that. So what this is going to do is it's going to give us a new entry in our list after each line is split. So for the final time in this, what I'm sure is going to end up being a pretty long video, I'm going to add a bunch of print statements and then we're going to take a look at the result. All the print statements are in place. Let's run it and see what goes on. Okay, we see our initial split. It's split on the spaces, and we have a, test, and string as isolated strings within our list. No spaces in there anywhere because it's split upon the space. Now, if we see when we split across T, we see we have a test, no T because that's where it's split, then a space and an S, again no T in string, and then finally the ending ring there. When we did the R split, we got the same exact results because we didn't specify a max time that we should be splitting. Now when we partitioned with T, we see something interesting compared to split. We have a test as we did when we split across T. However, we see that in the middle here we have our first T, and it continues on with the space string. So it just partitioned that once and we didn't actually split on this last T, compared to when we did right partition on the T. The first lowercase t is intact, then we have the start of our last word string where we have our uppercase S, then the T that we partitioned on, and then finally we have our ending ring. For our split lines example, when we didn't have any Newline characters in there, it just put the entire string in a single element list. But when we added some Newline characters into our string, we see that we get the A, test, and string entries there. Again, this is most useful for when you are reading through a file, so you can just read the entire file and then do a split lines call against the contents of the file and pop that into a list and carry on your business. Well, that wraps up this video. As you can see, there is a lot you can do with strings. Which of the things I covered is your favorite, or did I miss something? Leave a comment down below to let me know. As always, today's code will be added to the Understanding GitHub repo, so check out the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, please leave a comment down below. To keep up with the series, consider subscribing. Thanks for watching.